Question 11. Determine the adjacency matrix that represents this graph. Now, sometimes instead of going through the process of elimination and finding out which is your correct multiple choice solution, it's just easier to do the question. So we're going to go ahead and do that. Now, if we look at my graph, you'll notice I've got the vertices Q, R, S, and T. So if I want to draw an adjacency matrix representing that, I need to include those 4 points. So we're going to do that here. Q, R, S, and T. And also vertically Q, R, S, and T. Now looking back at our graph, you'll notice there is no directional component on the edges. So that means my adjacency matrix is going to be a mirror image along the diagonal. So let's start filling in some information. So from Q to R, you'll notice there is one connection there. So Q to R is going to be 1. Right? Also notice Q to Q, it's going to be 0. The only time you would actually get a number from Q to Q is if you had a loop, and we don't have that in this scenario. So Q to Q will be 0, Q to R is 1, Q to S, all right, also 1, and Q to T will be 0. Okay, let's have a look at R. R to Q, there's no direction, so we've got 1 there. All right, R to R, there's no loop, so that's going to be a 0. R to S is 1, R to T is 0. Okay, do the same for S. S to Q is 1, S to R is 1, S to S, there's no loops, so that's going to be 0. S to T, there's no edges connecting there, so that's also going to be a 0. And you'll notice T is not connected to anything with an edge, so we could just go 0, 0, 0, 0. Okay, so having a look at our adjacency matrix here, you'll notice if I was to draw a diagonal through here, the top part of that diagonal is a mirror image of the bottom part of that diagonal. Now, having a look at our solutions, A straight up because that's got only 3 vertices in it. You'll notice that C can't be done because T is not connected to anything, but it's got a 1 in there. B is a possible solution, and D was a possible solution, but D is saying there's multiple edges, so it's not that one. So the answer is B. Question 12. The activity times in the project network shown are in days. The greatest float time for a non-critical activity in this network is... Okay, in order to determine float time, you first need to decide what your critical path is, because the float time is the amount of time a task can be delayed without it causing a delay to the other tasks in the project. So our critical path all deal with tasks that can't be delayed. So let's determine which ones those are first. So if a task cannot be delayed, then 9 times out of 10, its earliest start time is going to be the same as its latest start time. So having a look, A 0066, B, D, F, and G is our critical path. None of these tasks can be delayed. So that leaves us with C and E that are possible jobs that can be delayed. So in order to find out our float time, we can use a little formula. So our float time will equal our latest start time minus our completion time minus our earliest start time. In the case of E, you'll notice that we have 17, 5, and 10. So the float time for E would be 17 minus 5 minus 10, which equates to 2. And for C, we have 12, C, and 6. So our float time for C is 12 minus 4 minus 6, which is also equal to 2. So the greatest float time for a non-critical activity in this network is A, 2 days. If you can't remember this formula, an easy rule of thumb, if the test is set up like this with our earliest start time and our latest start time side by side horizontally, you could just think, if I need to find the Float time, I go right, middle, left. Question 13. Which of the following is a planar graph with 5 vertices and 4 faces? Well, if we have a look at our selection here, A, B, C, or D, you'll notice straight away that C only has 4 vertices, so that one's out. Now we need to look at our faces. When we look at the faces of a planar graph, what it's referring to is also the regions, and the regions are separated by boundaries. So if we have a look at A, you'll notice it has one region here, second region there, a third region there, and also has one region on the outside. Whereas B, we have 1, 2, 3, 4, 5. And for D, we just have one region. So which of the following is a planar graph with 5 vertices and 4 faces? The solution is A. Question 14. A sample of university staff and students were asked whether they preferred catching public transport or driving their own car to university. The data collected is shown in the table. What percentage of university students prefer to drive their own car? Looking back at this question, let's highlight the key bits of information. First bit is percentage of university students, and the second bit is drive their own car. So when looking at the two-way table above, we don't care about everybody who was surveyed for the purpose of this question. We're purely looking at, out of the students surveyed, what percentage preferred to drive their own car. So if we set up a little fraction here, right, in order to find the percentage of something, remember we take a score and divide it by its total. So we can see how many prefer to drive their own car. Well, that's 12. But how many were surveyed altogether? Well, there was 60 surveyed altogether. And to change that into a percentage, we would multiply it by 100%. So we'll get 0.2 times 100%, which will give us 20%. So the solution is C, 20%. Question 15. The graph shows the value of 3 different annuities over time. Which of the following statements give a plausible explanation for the different values after 7 terms? Now remember, an annuity is where we're making a regular payment at a regular interval. Whether we're putting this money into a bank account to increase funds over time, or whether we're paying off a loan for a house, something like that. So let's have a look at our statements here. A. Annuity 1 and Annuity 2 have higher regular deposits than Annuity 3. Well, if we have a look at our graph, we'll notice that Annuity 1 goes up quite quickly. Right? Annuity 2, a little bit more so than Annuity 3, and Annuity 3 is the lowest here. So Annuity 1 and 2 have higher regular deposits than Annuity 3. Well, that's plausible, because if we think about it, if they're all working on the same interest rates, and they're all accruing, let's say, 10% interest rate for each term, then you would expect the one with the higher regular deposit to go up quicker. So A looks pretty good. So I'm just going to put a little dot here to signify A could be a possibility. Okay, B. Annuity 1 and 2 have shorter interest terms than Annuity 3. Well, that's not true, because if we have a look at our x-axis where we have the number of terms, right, you'll notice that all of our dots, let me just erase the lines I drew, you'll notice that all of our dots align with each other. So that means they're all being done at the same term. So B is off the cards. C. Annuity 2 and Annuity 3 have a lower initial value than Annuity 1. Well, that's not true either, because if we have a look at our y-axis, you'll see that they all start off at the $500 mark. So C is not a choice. D. Annuity 2 and Annuity 3 have higher interest rates than Annuity 1. So for this statement, it's easy to think of our payments being exactly the same. So starting off at $500, we put in $100 each term. Now, if we're putting in $100 each term, then the one with the highest interest rate is going to increase quicker. But if we have a look back to our graph, we had annuity 1 up the top, and then we had annuity 2 and then annuity 3 underneath that. But D is stating that annuity 2 and 3 have higher interest rates than annuity 1. So we know that is also not the case, which leaves us with the final solution of A.